Hello everyone. For this session, I'm going to show you how to find the magnitude of the vectors in a given situation where such that the resultant force of all the vectors becomes zero. Before I go into any given problem, let's come to terms with a few basic terminology. Now, first of all, we're going to deal, like this topic suggests, very much with vectors. A vector is usually given by a straight line with an arrow in a given direction. Now, throughout this video, you're going to hear me use these few terms. First of all, with this given vector, you watch the direction of the arrow is pointing to the right. So on the right of the arrow, which I'm going to mark out in blue, this point here is known as the tip of the vector. Or maybe in a given situation, a specific vector can be forces, or a velocity, or displacement. But generically, it's called the tip of the vector. And the other end, which I'm going to mark out in green, the other end is known as the tail of the vector. So one end is a tip, one end is a tail, depending on the direction of the arrow. So in this case, I say again, the arrow is pointing to the right. So the right side is the tip, and the left side is the tail. Now let's go into this problem given here. This problem is actually in your worksheet, but if you have not seen your worksheet, it's alright. Now we know in this diagram, the mass is suspended by two wires, wire 1 and wire 2. And we know by Newton's second law, they are stationary. That's when acceleration equals 0 and resultant force is 0. So we identify the three different vectors, and that's the tension in wire 1, tension in wire 2, and the weight of the 40 kilograms. Now we let the tension wire 1 be T1, the tension wire 2 be T2, and we know the mass is 40 kilograms, so let's find the weight. Weight is actually equals to mg. And so 40 times 10, you give us 400 newtons. So that means we already have one given force, that's 400 newtons. But if you look at the diagram, there are two different angles, 30 degrees and 80 degrees. Now we're going to draw a vector diagram using 30, 80 degrees and the 400 newtons. Now before you draw the vector diagram, let's find a suitable scale. You have to use the trial and error method to find a suitable scale, but in this case, I already found it to be 1:50. So right now, specifically, 1 cm represents 50 newtons. And since I have a 400 newtons, so 8 cm represents 400 newtons. Now I'm going to draw the vector representing 400 newtons, which is 8 centimeters in length. And when you watch me draw, I actually draw a length that's longer than 8 centimeters. And then I mark out 8 centimeters. I say again, it's easier to draw a longer line and then erase the excess later than to extend a short line. And this weight is pointing downwards. And I label it 8 cm in brackets and then 400 newtons. Now, look at the diagram carefully. The angle between the vertical dotted line and the T2 is actually 80 degrees. And the vertical line is actually parallel to the 400 newtons. So when I draw the 400 newtons as shown in the diagram, I made sure the tip of T2 touches the tail of 400 newtons, and the angle between T2 and 400 is actually 80 degrees. I want to touch the tip of T2 to the tail of 400 newtons. Now on my diagram, I now measure 80 degrees at the tail of 400 newtons. And once I mark out 80 degrees, I'm going to draw a line that represents T2 and extends all the way to the other end of the paper. I don't know how long T2 is going to be, but it's better to draw, as I said earlier, better to draw a longer line and erase it later than to extend a shorter line. So now the tip of T2 is actually touching the tail of 400 newtons. And mark out 80 degrees. Label the vector T2. Next, the tip of 400 newtons. How is the tip of 400 newtons related to T1? Now the tip of 400 newtons, when it touches the tail of T1, it forms an angle of 30 degrees, as shown in the diagram. Now do not be afraid to extend lines inside your the given diagram, because sometimes it's needed to find the relevant angles. Just don't solve your problem in the diagram, right? Sorry, don't solve your problem in the given diagram. Now I have to measure a 30-degree angle at the tip of 400 newtons so that I can draw the tail of T1 to touch the tail. I have to extend the tail of T1 to touch the tail of T2. So this time around, what I have here, the tip of T1 touches the tail of T2. So there you go. I have this vector diagram now. It's complete. I have the tip of T2 touching the tail of 400, the tip of 400 touching the tail of T1, and the tip of T1 touching the tail of T2. Now as shown here, see I'm erasing the excess line. It's much easier that way. After I erase the excess line, I'm going to measure the length of T1. And T1 is measured to be 8.4 centimeters. T2 is measured to be 4.3 centimeters. Now you look at the scale, 1 cm represents 50 newtons. Therefore, the magnitude of T1 is actually 8.4 times 50. And the magnitude of T2 is actually 4.3 times 50. And just using a calculator, we get the magnitude of T1 and T2. I want to emphasize again, look at the direction of the arrows, it forms a closed loop. Now looking at this diagram, how do we know the vectors form a closed loop? Because when you start at vector here, A, let's say this point is A, this point is B, and this point is C. Now when you follow the direction of the arrow, A goes to B. B goes to C, and C goes back to A. So the direction of vector is A to B to C and then back to A. It forms a closed loop. There is no resultant force.